So imagine this. You wake up to the kind of headline that doesn't make sense, not in a world governed by satellite surveillance, climate modeling, and decades of meteorological precision. A lake has appeared in the desert. Not just any desert, but one of the driest, most lifeless stretches of land on the planet, the Atacama. At first, it sounds like an exaggeration. A translation error, maybe. Some blog spinning a local rainstorm into something dramatic. But then the images start flooding in, high-resolution satellite photos, drone footage, on-the-ground reports, and suddenly, it's not a rumor anymore. There's water. A lot of it. Sprawling. Still. Shimmering beneath the sun. A pale blue wound carved into the heart of the desert, and no one can explain how it got there. No one even saw it coming. The images are haunting. A vast, flat sheet of water stretched across a cracked, rust-colored basin. The surface glows in the harsh light, mirroring the sky so clearly that it looks unreal, like a rift between dimensions, a glitch in reality itself. The surrounding hills are dry and dusty, untouched by rainfall, silent in their shock. There are no rivers feeding into it, no clouds above, no signs of flooding or erosion. Just water. Tranquil and sudden and completely out of place. And it isn't disappearing. In a place like the Atacama, any moisture that touches the ground should evaporate almost instantly. That's just how it works. The sun is relentless. The soil is bone dry, nearly sterile. Even the air fights to hold on to the tiniest particles of water. Rain, when it happens, is a rare and dramatic event, often violent, always fleeting. But this isn't a storm's aftermath. This isn't runoff from the mountains or a flash flood carving a temporary path. This lake, for lack of a better word, is holding. The water isn't boiling away. It isn't sinking. It's just there, as if it's always been there. As if the desert had made room for it, waiting in silence for something to break the drought of millennia. Locals are the first to spot it. A few hikers, maybe, or workers traveling a well-worn route across the barren landscape. What they see stops them in their tracks. Vehicles roll to a halt. Phones come out. People stare in disbelief. 1 minute, they're surrounded by desolate rock and salt flats, and the next, they're standing before an expanse of water so vast and so unnatural in context that it feels like a mirage, except, it's not. Cameras confirm it. News spreads quickly. Soon the world is watching. The Atacama, long a symbol of barrenness, becomes the center of a quiet storm of global curiosity. Scientists rush to coordinate site visits. Journalists fly in. Environmental agencies request satellite data and send out field teams. But no one has a good answer. No seismic activity had been recorded. No unusual weather patterns had been detected. No known geological event could explain a sudden, standing body of water appearing overnight, especially not here. And here's what makes it even more unsettling. The lake is beautiful. It shouldn't be, but it is. Perfectly still. Glassy. Clear enough to see straight to the bottom in many places, revealing smooth sediment and clusters of strangely undisturbed stones. There are no reeds, no algae, no insects skating across the surface. No signs of life, but also no signs of decay. No debris. No scum. Just silence and reflection. It feels curated somehow. Designed. Too clean to be natural, too subtle to be engineered. Tourists begin to show up. Carefully at first, then in growing numbers. Scientists cordon off the area, but the images have already gone viral. The lake becomes a destination, a mystery, a conversation. It draws photographers, influencers, climate watchers, spiritual seekers. Some come with reverence, others with curiosity, but all of them feel the same unshakable thing. This place is not behaving the way it should. This place has changed. And something about that change doesn't feel random. Helicopters buzz overhead. Tents are set up along the periphery. Instruments are unpacked and deployed. Hydrologists take samples, climatologists run projections, and geologists dig into the surrounding terrain. Everyone is asking the same question, spoken in different languages, through different lenses. How does something like this happen? Why now? Why here? Because if you know the Atacama, if you've studied it, walked through it, or even just read about it, you understand how impossible this is. The Atacama isn't just dry. It's otherworldly. NASA has used it to simulate Martian conditions. Its landscape is so inhospitable, so stripped of organic material, that some parts resemble lunar regolith more than Earth. It's not just empty, it's sterile. The kind of place where water doesn't just disappear, it gets erased. Yet here it is, rippling gently in the afternoon breeze, glinting under the gaze of satellites, holding its shape defiantly. There are no answers yet, only silence and speculation. And as days turn into weeks, one thing becomes very clear. Whatever this is, whatever caused this, it's not normal. And it's not over. Now, before we continue, we would like to encourage you to consider liking the video and subscribing in order to support us in this journey. In the first days following the lake's discovery, theories swirl like desert wind, thin, scattered, difficult to hold onto. The scientific community is cautious, as it always is in the face of the unexplained. But eventually, a thread begins to emerge. Not a full explanation, not yet, but a hypothesis grounded in physical possibility, wrapped in mystery. One idea begins to take shape, quietly gaining traction behind closed doors and in early reports. The theory? That the water didn't fall from the sky or bubble up from a spring, but instead seeped upward from the earth itself, released from a hidden reservoir far beneath the surface. An underground aquifer, long buried and long forgotten, may have ruptured. At first glance, it sounds reasonable. Aquifers are real. They stretch like unseen veins beneath continents, vast and ancient networks of water trapped in porous rock. Most lie deep below the Earth's surface, collecting rainwater over centuries, sometimes millennia. In some parts of the world, they sustain entire civilizations. In others, they remain untouched, hidden beneath the crust in regions too dry or too remote to be explored. But in the Atacama? That's the catch. The Atacama's geology isn't known for generosity. Its soil is salt-encrusted and hostile. Its subterranean structure, at least in the regions mapped so far, doesn't suggest any major water table. No known aquifers. No records of subsurface water migration. And yet, if such a chamber did exist, if there were some secret pocket of water trapped deep beneath the desert floor, it would take a precise, violent kind of disruption to set it free. Something had to change. Experts begin scouring geological records, hunting for anomalies, tremors, fault activity, any event that might signal a structural shift underground. And sure enough, something strange appears in the data, a cluster of microseismic activity, registered just days before the lake was discovered. Not strong enough to shake buildings. Barely noticeable without sensitive equipment. But there, nonetheless, a flicker in the Earth's rhythm. A pulse. Seismographs showed a pattern of vertical motion, subtle and sharp, unlike the lateral shearing typically caused by tectonic movement. Some researchers suggest it could have been the collapse of a subterranean chamber, the kind that happens when an underground cavern, drained of its support, suddenly caves in. If an aquifer had existed under extreme pressure, hemmed in by layers of dense rock, such a collapse could rupture the seal, forcing water upward with explosive force. But here's where things get even more curious. There was no explosion. No steam vents. No geysers. No outward signs of upheaval. The surface above the lake remains eerily undisturbed, flat, unbroken, as if the water had been placed there rather than forced out. If something erupted from below, it did so without leaving a scar. And yet, the idea lingers. That somewhere deep beneath the Atacama, a pocket of water, ancient, undisturbed for eons, finally found a way out. Maybe tectonic stress had been building along a vertical fault, silent and slow. Maybe a fracture widened just enough to breach the seal, allowing water to rise through porous stone, layer by layer, until it reached the surface. The journey could have taken hours, or days, or years. No one knows. What matters is that the result is undeniable. A lake, perfectly still, formed not by weather or river, but by release. Scientists begin to test the water. If it came from an aquifer, it should carry a very specific signature, a kind of mineral fingerprint that tells a story of depth, age, and origin. The samples are sent to labs. Spectroscopy scans are run. And sure enough, the water reveals a fascinating truth. It's incredibly pure. Not pristine, like distilled water, but untainted by surface runoff, unpolluted by human activity. It contains minerals consistent with long-term contact with volcanic rock, basalt, andesite, and traces of obsidian. Some even speculate it may have been thermally shielded, protected by layers of geothermal insulation for untold centuries. That level of purity raises another question. If this water came from an underground chamber, how old is it? Radiocarbon analysis of entrapped gases begins. Isotopic ratios are examined. The results, though early, are astonishing. The water appears to be ancient, thousands of years old, perhaps older. Unmoved, unseen until now. And so, the story begins to shift. No longer just a lake that shouldn't exist. Now a revelation. A rupture. A moment in time when something long buried whispered its way to the surface. And the implications are vast. Because if this can happen here, in the driest place on Earth, what else lies beneath us, waiting to rise? As the investigation deepens, attention turns from the surface to the subterranean, from what is visible to what is hidden. Geological surveys begin anew, this time with more sophisticated tools and renewed urgency. Airborne ground-penetrating radar is deployed across the surrounding desert, scanning for anomalies beneath the Earth's crust. Teams set up mobile seismology stations to listen more closely to the Earth's whispers. There's a growing conviction that the truth lies underground, not just meters below, but perhaps kilometers deep, in ancient layers that haven't shifted in epochs. The more they look, the more peculiar things become. Buried beneath the dusty crust of the Atacama are stratified bands of volcanic rock, evidence of long-dead eruptions that once shaped the Andean edge. But in between these hard-baked layers, researchers find signs of something softer, sediment that appears displaced, compressed, and subtly curved in unnatural ways. It's the kind of subtle warping that suggests movement, pressure, and, crucially, expansion. Not all at once, but gradually. Like something beneath the rock had started to swell over time, gently lifting and bowing the stone above until finally it cracked. It's in these layers that they find signs of mineral leaching, veins where silica and manganese have been drawn upward by moving fluids. These traces aren't widespread, but they're fresh, unoxidized, and linear. Geologists describe it like finding fingerprints on a fogged mirror, evidence that something passed through here, recently, and left behind a chemical trail. The working theory is that this is the path the water took. Not an explosive eruption, not a geyser or a spring, but a pressurized seepage, one that threaded its way upward like a needle through fabric, exploiting microfractures and ancient weaknesses in the bedrock. But the most intriguing part of the discovery isn't the path the water took, it's the possible source of that water. In a surprising twist, deep borehole data gathered decades ago by mining companies resurfaces. Back in the late 1980s and early 1990s, exploratory drilling had been conducted across several regions of northern Chile, including stretches of the Atacama Desert. These boreholes, drilled to assess mineral wealth, were abandoned after turning up little of commercial value. But what they did record, in brief, overlooked entries, were elevated humidity readings at depths over 3 kilometers. At the time, it was dismissed as equipment error or inconsequential hydrothermal activity. Now, those forgotten logs take on new significance. Several of those boreholes align roughly with the location of the newly formed lake. If there was once a vast, super-deep aquifer trapped beneath impermeable rock, sealed off for millennia, then perhaps those old boreholes were merely faint echoes of something far more massive, a reservoir that extended laterally across dozens, if not hundreds, of kilometers. Such a body of water, if real, would be unlike any aquifer typically studied. It wouldn't be fed by rain or rivers. It would be fossil water, locked underground since the last ice age, untouched by climate, sealed off by geological events long forgotten. And this theory carries unsettling implications. Because if a hidden water system of that scale exists beneath the Atacama, and it has now begun to move, even slightly, then something must have disturbed the balance. Geologists theorize that subtle tectonic activity, possibly influenced by long-term subduction of the Nazca Plate, may have altered the pressure dynamics below the surface. A release valve of sorts could have formed, not in a violent crack, but in a slow, widening fault that allowed ancient water to bleed upward. Not all at once, but just enough to fill the basin now shimmering in the desert sun. Satellite altimetry data adds another layer to the mystery. Analysis over the past 10 years shows that the land around the lake has been very gradually rising, mere millimeters per year. Not enough to be noticeable, but enough to suggest something beneath the crust is pushing upward. Some interpret this as further evidence of subsurface pressure. Maybe it's thermal expansion, or slow inflow from deeper, geothermal systems. Or maybe, just maybe, something is displacing the ground from below, a fluid system shifting beneath the lithosphere, now surfacing in one isolated, unassuming location. But even as researchers try to model the phenomenon, they face an unnerving problem. The system seems stable. Too stable. By all logic, this water should have started evaporating rapidly in the desert heat. But it hasn't. Measurements show only marginal decrease in water level over time. There's no active inflow, no tributary, no known feeder source, and yet it lingers, persistent, stubborn, and calm. Some speculate that there may still be pressure beneath the surface, continuing to push water upward in small amounts, just enough to replenish the lake without making waves, literally or figuratively. And still, the mystery holds. What kind of subsurface mechanism can maintain that kind of equilibrium? What kind of ancient system, dormant for so long, could awaken so precisely and then stop, as if fulfilling its purpose? The Atacama has always been a place where time seems to stand still. But now, beneath its crust, time may be stirring once again. Still, for all the intrigue the aquifer theory offers, not everyone in the scientific community is convinced it holds all the answers. Some hydrologists raise an eyebrow at the idea of such a massive volume of water quietly slipping through ancient rock without a more noticeable seismic disturbance. Others argue that while the subterranean water migration explains certain elements, it doesn't fully account for the lake's pristine clarity or its unusual mineral profile. So naturally, minds begin to look east, toward the towering, snow-capped Andes that rise like a ragged wall on the desert's horizon. The Andes Mountains, after all, are not just a backdrop to this mystery, they're an ancient, dynamic engine of geological complexity. Spanning the entire western edge of South America, they cradle within them glaciers, ice caps, and high-altitude aquifers that hold enormous volumes of water. Though the Atacama sits in the rain shadow of these mountains, effectively starved of moisture, the two regions are still intricately connected by deep, unseen geological veins. And in recent decades, that connection may have shifted in ways we're only beginning to understand. Climate data from the past 50 years paints a sobering picture. Across the Andes, temperatures have risen incrementally but steadily. Glaciers once thought eternal have begun to retreat, not dramatically, not in sudden collapses, but in the slow, relentless manner that escapes headlines yet carves quiet warnings into the landscape. Some of these glacial bodies have lost up to 40% of their mass since the 1980s. Meltwater is collecting in high-altitude basins, forming ephemeral lakes and reactivating ancient glacial streams that had been dry for centuries. What's particularly fascinating and relevant is that some of these newly awakened streams don't follow familiar paths. Satellite data has captured shifts in hydrological flow, water moving not southward or westward, as it traditionally does, but disappearing into sinkholes and karst systems that burrow beneath the mountains. In certain cases, meltwater has been observed vanishing into subglacial fissures, its path unknown, untraceable. Scientists call it lost runoff, and up until now, it's been a hydrological curiosity, a footnote in glacier studies. But what if some of that water didn't stay lost? What if, over years or even decades, it slowly tunneled its way through limestone pockets, eroded mineral barriers, and found its way through some forgotten channel deep beneath the Andes? A naturally occurring aqueduct, hidden beneath miles of rock and soil, reactivated by a trickle of meltwater that never stopped flowing. It's not as dramatic as an eruption, nor as exotic as subterranean mantle water. But it's possible, and in many ways, it's even more unsettling because of that possibility. It doesn't require exotic physics or alien minerals. It just requires time. Silent persistence. The quiet reshaping of a continent beneath our feet. Supporting this theory are a series of minor but consistent anomalies picked up by satellite gravity measurements over the past 2 decades. These measurements, often used to track ice loss, also detect changes in underground water storage. And in the region just east of the Atacama, subtle shifts have been noted, slight decreases in mass in high-altitude zones, and minute increases in mass closer to the desert floor. Not enough to draw immediate alarm. But in hindsight, these might have been the fingerprints of a slow redistribution of water, from mountain to desert, from glacier to mystery lake. Geochemists also note that some of the elements found in the lake, particularly calcium, strontium, and traces of barium, are often associated with high-altitude glacial erosion. When meltwater grinds its way through ancient rock, it pulls minerals into suspension. These minerals become the chemical signature of the water's origin. And though the lake in the Atacama also contains strange rare earth elements, its overall profile does share a few eerie similarities with samples taken from glacier-fed lakes in the Peruvian and Chilean Andes. It's not a perfect match, but it's close enough to raise eyebrows. And here's where it gets even more compelling. The lake is perfectly positioned in a slight depression that geologists now believe may have once been the terminus of an ancient riverbed, a dry arroyo so old it had been misidentified as a fault line. If this feature was once active in prehistory, when the climate was different and glaciers more robust, then perhaps all we're witnessing now is a brief return to a long-dormant natural state. A hydrological echo from a time when the land was alive in different ways, now reawakened by the quiet rage of melting ice and shifting terrain. Yet, despite this promising direction, questions still linger. Why now? Why this exact spot? Why isn't the lake expanding or shrinking more visibly? If the source is meltwater, why isn't there a defined inflow or outflow, no visible stream or trickle, no murmuring of movement? It's almost too quiet. Almost curated. As if the lake appeared not through a chaotic event, but through a series of extraordinarily timed, perfectly aligned natural coincidences. The kind that defy probability. The kind that makes even the most grounded scientists feel the unsettling tug of something they can't quite name. As fascinating as the possibility of glacial meltwater infiltrating the Atacama Desert may seem, the narrative doesn't end with a simple geological process of ice retreat and underground water flow. In fact, the more researchers dig into the history of the Atacama and the Andes, the more peculiarities emerge that challenge even the most conventional explanations. To understand why this phenomenon has been so difficult to pin down, it's important to look at the very nature of the desert itself, and the often overlooked geophysical forces that shape it. The Atacama Desert is often described as a place where the Earth's natural extremes come together: scorching heat during the day, freezing cold at night, a total absence of humidity, and an almost complete lack of precipitation. Yet what most people fail to realize is that these conditions aren't entirely natural. The Atacama's dryness has been deeply influenced by one of the most powerful geophysical forces in South America, the rain-shadow effect. Created by the Andes Mountains themselves, the Atacama sits in the path of moist air from the Pacific Ocean that's blocked by the towering peaks. As air masses are forced upward, they cool and release moisture as precipitation, but once they cross over the mountains, they descend into the desert as dry, arid air. It's a process that's been in play for millions of years, effectively turning the Atacama into one of the driest places on Earth. However, this complex weather pattern doesn't explain the sudden appearance of a substantial body of water, especially one that doesn't evaporate in the searing heat. The key, it seems, lies in understanding just how the desert and its surrounding mountain range are continually evolving. The Andes are an active tectonic zone, constantly reshaped by the movement of the Nazca and South American plates. It's within this dynamic framework that geologists are beginning to suspect that the region's deep-seated geological features that have been dormant for eons, might be playing an unexpected role in the creation of the lake. It's easy to imagine that when most people think of tectonic activity, they picture volcanic eruptions or massive earthquakes, the kinds of events that send shockwaves through the ground. But this isn't the only form of tectonic activity that can reshape a landscape. The movement of these plates also results in a constant shift of pressure within the Earth's crust, a slow, undramatic process that occurs over centuries but can have immense, long-term effects on the surrounding region. Deep beneath the Atacama and the Andes lies a vast network of fault lines, fractures, and hidden geothermal chambers, many of which are almost entirely unknown to modern scientists. Some geologists now believe that these underground structures could have played a crucial role in the emergence of the Atacama Lake. As the glaciers of the Andes have retreated and shrunk over the last several decades due to rising temperatures, vast underground water channels that were once sealed away have begun to shift and settle into new paths. It's as though the Earth itself is releasing water that has been trapped beneath its surface for millennia, water that has been waiting for the perfect set of conditions to emerge. As these ancient pockets of water gradually seep through faults, cracks, and chambers in the crust, they could have traveled downward into the dry, seemingly impenetrable desert, a hidden, slow-moving river beneath the Earth's skin, now breaking free into the open air. In the Atacama, these fractures may have provided just the right conditions for the water to emerge through the surface, creating a pool that could not only survive but thrive despite the harsh desert conditions. The incredible part of this theory is that the water isn't simply flowing or draining away, it's staying. This suggests that it's not just the water that has come to the surface, but something else, something more intricate and specific. There's an argument that perhaps the water has formed a symbiotic relationship with the local geology itself, utilizing underground mineral deposits to maintain its stability. The porous rock, for instance, may allow the water to remain trapped for extended periods, further preserving the lake's presence despite the desert's scorching sun. While no one has yet mapped out the exact flow of these underground channels, the evidence does point to a highly complex interaction between the land's deep layers. Geophysicists have already recorded subterranean heat signatures beneath the Atacama, indicating the presence of fluid or semi-fluid bodies within the Earth's mantle. These heat signatures, while not enough to suggest volcanic activity, are significant because they suggest that geothermal processes could be aiding in the rise of water to the surface. This kind of geothermal activity, although subtle, might explain why the water is so stable, almost undisturbed by the extreme temperatures of the desert. Even more interesting is the fact that this form of underground water migration may be a relatively recent phenomenon. If the water that emerged in the Atacama had been there for thousands of years, it would likely have evaporated long ago, absorbed by the arid desert sands. The sheer persistence of this lake in such a harsh environment suggests that something about the water's composition is changing. And as glaciologists point out, the timing is crucial. If the lake's formation coincided with recent changes in glacial patterns and the accelerated melting of high-altitude ice, it stands to reason that the environmental impact of these changes might have altered the very pathways through which the water reaches the surface. But the most striking aspect of the glacial meltwater theory lies in its implications for how we understand our planet's water systems. The idea that water, potentially thousands of years old, could be trapped in underground reservoirs, waiting for the right geological conditions to surface, challenges everything we know about hydrology. Water, traditionally thought to be a dynamic, circulating substance, moving in rivers, lakes, and oceans, is shown to have far more complexity than we could have imagined. The fact that it could be locked away in the very bones of the Earth, only to be released by the hand of time and tectonic forces, opens the door to new questions about the true nature of water's cycle. There are many mysteries left to unravel, of course. But the possibility that glacial meltwater from the Andes is responsible for the Atacama Lake offers an elegant solution to one of the planet's most baffling natural phenomena. It suggests that sometimes, the answers to our questions lie not in the sky or in outer space, but deep beneath our feet, hidden beneath layers of rock and ice that have waited millennia to reveal their secrets. With every passing day, as more data is gathered and more hypotheses tested, the picture begins to clarify, showing us a landscape of our planet that is as complex and unpredictable as the forces that shaped it. While the glacial meltwater theory provides a fascinating glimpse into the complexities of the Earth's underground water systems, there's another possibility that might explain the sudden appearance of a lake in the heart of the Atacama Desert. This theory, though somewhat more outlandish, has captured the imagination of many and introduces a concept that many may not have considered before. What if this mysterious lake didn't come from the Earth at all? Instead, what if it arrived from above, carried by the vast, unknowable reaches of space? Now, before you dismiss this notion outright, let's dive into the strange and compelling world of meteorites and cosmic impacts. Imagine for a moment that a large chunk of space debris, perhaps a meteorite or even a comet, crashed into the region. This would not be a typical meteor strike, one that leaves behind a large crater or a burning explosion. Instead, picture something far more subtle, a cosmic object carrying with it not just rock and metal, but also the potential for an unexpected, even paradoxical consequence: the introduction of water to one of the driest places on Earth. Meteorites have long been thought to carry essential elements that could seed life on Earth, and there's a growing body of evidence suggesting that many of them contain water. In fact, some of the most famous meteorites that have made their way to Earth have been found to possess trace amounts of water, often in the form of hydrated minerals. The scientific community has speculated that this might be one of the reasons life, as we know it, could have originated, not just from the Earth's resources, but also from materials carried here from the outer reaches of our solar system. So, the idea of a meteorite impacting the Atacama Desert, potentially introducing water, isn't as far-fetched as it might sound. The theory starts with an impact event. Now, unlike the destructive meteor showers that light up the night sky, this particular meteorite would have been small enough to escape notice. Its trajectory might have been nearly undetectable by our current space monitoring systems, making its impact all the more perplexing. And if it landed in the right spot, a low-lying basin within the desert, it might have provided the perfect setting for the water to pool and settle, creating what we see today, a shimmering body of water where none should be. But let's explore this theory a bit further, because it's not just about the water itself. The concept of spacefaring water brings with it a whole series of questions that could revolutionize our understanding of planetary science and meteorite impacts. Some researchers have suggested that the composition of meteorites could play a huge role in the nature of the water they carry. You see, not all meteorites are the same, and some contain minerals and metals that aren't typically found on Earth. For example, meteorites from the asteroid belt often contain rare earth metals like europium and gadolinium, elements that have been detected in the Atacama Lake. These metals are usually associated with high-energy processes, like those occurring in distant stars, or in the intense environments of space. If this lake's water has a composition linked to such rare elements, it might support the idea that the water didn't originate from Earth at all, but rather from somewhere far, far beyond. What makes this idea even more compelling is the concept of what we call impact water. Water is not typically a feature we associate with space objects, but there's mounting evidence that many comets and asteroids in our solar system may contain vast amounts of water, locked in ice form. When these space rocks crash into a planet, especially a dry one like Earth, the sudden compression and heat generated by the impact could melt the ice, releasing water into the environment. While this doesn't explain the formation of a large crater or fireball, it's possible that the water from such an event could simply seep into the ground, or in the case of the Atacama, pool into a low spot, forming the mysterious lake that now exists. One intriguing aspect of this theory is the lack of visible damage to the desert's surface. Normally, a meteor impact would leave behind a noticeable crater or other signs of its passage. Yet, in the case of the Atacama, there are no major impact craters, no large debris fields, no sudden shifts in the landscape. This might suggest that the meteorite in question wasn't large enough to create a traditional impact site. Instead, it could have been a smaller, more subtle object that didn't strike the ground with the usual force, but rather slowly deposited its contents in the form of water, hidden beneath the surface and waiting to be uncovered. Now, let's consider the timing of this event. While meteorites have been striking Earth for billions of years, the appearance of this lake in such a dry, uninhabited part of the world raises questions about why it has happened now. Could there be a connection between this phenomenon and the ongoing exploration of space, or perhaps even an unexpected cosmic event that brought a cluster of debris toward our planet? It's not entirely outside the realm of possibility that a larger cosmic event, like the shifting of asteroids or a change in the way space objects interact with the Earth's gravitational field, could have contributed to this mysterious arrival of water. In fact, some experts are already suggesting that recent increases in cosmic activity, including asteroid impacts and the rising frequency of meteor showers, could be linked to changes in our planet's environment in ways we're only beginning to understand. The cosmic water theory is intriguing because it presents a series of possibilities that aren't immediately apparent. It pushes the boundaries of what we consider normal in terms of meteor impacts, and it forces us to consider the idea that our planet, and particularly regions like the Atacama Desert, might not be as isolated from the cosmos as we think. The fact that water, something so essential to life as we know it, might have arrived here from the vast reaches of space gives a new sense of wonder to the desert's arid landscape. But before we jump to conclusions, it's important to remember that there's still a lot we don't know. The specifics of the Atacama Lake's origin are shrouded in mystery, and while the space impact theory is certainly captivating, it's just one possibility in a much broader spectrum of potential causes. What remains clear, though, is that the world's most mysterious desert, once thought to be a place where nothing could survive, is now home to an enigma that might forever change how we think about life on Earth and in the cosmos. As we stand on the edge of this unfathomable discovery, a vast, unexplained lake in the driest desert on Earth, it's difficult to not be struck by the profound implications this event could have on humanity's future. Beyond the mystery of how it appeared, there are questions about what it could mean for us as a species. If this sudden body of water were to hold any kind of cosmic significance, it could signal something much larger than just a scientific anomaly. It could mark a shift in our understanding of the world, our planet, and even the universe. First and foremost, the very existence of this lake in such an unlikely place challenges our preconceived notions about the natural world. The Atacama Desert, one of the most inhospitable environments on Earth, has long been seen as a place where life simply couldn't thrive, where the laws of nature seemed unyielding and unchangeable. But here we are, witnessing an event that defies the natural order of things. A body of water, perfectly poised and stable in a region so dry that life struggles to exist in even the most basic forms, is forcing us to reconsider the limits of our understanding. Could this mysterious event be a sign that the Earth itself is far more dynamic, far more unpredictable, than we've ever realized? At the heart of this mystery lies one simple, profound idea: the Earth is full of untapped secrets. For centuries, we believed that we know the planet's key features. We understand its weather patterns, its geological history, and its ecosystems, for the most part. But here, in the Atacama, we're confronted with something that doesn't fit. A shift has occurred, one that suggests there are things happening beneath the surface, both literally and metaphorically, that we can't fully grasp. And that leaves us with a question that humankind has struggled with for millennia: how much do we truly know about the world we live on? But this goes beyond our knowledge of the Earth. The sudden appearance of this lake, whether it's from deep Earth water, a meteorite, or some other unknown cause, speaks to a deeper, more existential concern: the fragile and interconnected nature of life itself. The fact that we've only just begun to scratch the surface of what lies beneath the Earth's crust, and in some cases, even below the ground, challenges our notions of control and certainty. If there are forces at play beneath our feet that can surprise us in such dramatic and inexplicable ways, what else is out there, waiting to be discovered? What other mysteries lie hidden, not just in the deserts, but in the deepest reaches of the planet? This realization could spark a new era of exploration, a period where scientists and adventurers alike push past the boundaries of the known world to uncover the secrets lying just beneath the surface. Imagine the possibilities. Could there be more places on Earth that hold hidden reservoirs of water? Could there be life forms we've never dreamed of, thriving in extreme, otherworldly conditions? The lake in the Atacama Desert might just be the first clue in a larger, more profound investigation into our planet's mysteries, a challenge to humanity to stretch the limits of exploration, and perhaps even our very sense of what's possible. But the implications of this discovery extend far beyond scientific curiosity. If, as some theories suggest, the water came from space, from a meteorite or a comet, it carries with it a message far more profound, one that challenges our understanding of life and our place in the universe. The very notion that water, a critical component for life, could have come from the cosmos forces us to confront a fundamental question. Are we truly alone in the universe? Is Earth the only place where life has been born, or are we part of a larger, cosmic story that stretches across galaxies and solar systems? The idea that water, an essential ingredient for life, could have been deposited here by forces beyond our comprehension could suggest that life itself is far more common, far more universal, than we ever thought. And if life is so abundant in the universe, what does that mean for us as individuals? As humanity continues to search the stars for signs of extraterrestrial life, could we be overlooking something much closer to home? Could the discovery of life beyond Earth be intertwined with our own search for meaning, purpose, and connection? This event in the Atacama Desert serves as a poignant reminder that the universe is far more mysterious and vast than we ever realized. Perhaps the answers we seek about our origins, our place in the cosmos, and our future lie not in distant planets or galaxies, but right here, on the Earth itself, waiting to be discovered. This brings us to another crucial point, the interconnectedness of all things. The appearance of this mysterious body of water in a desert could be a stark reminder that everything on Earth is interwoven, dependent on one another in ways that we might never fully understand. The water, the elements it contains, the life it might sustain, it all points to a delicate web of existence that stretches from the depths of the Earth to the stars above. What happens in one corner of the world, like the sudden formation of a lake in a desert, could have far-reaching consequences for the way we view the planet, the environment, and even our role in preserving the fragile balance of life. This is a wake-up call, urging us to reflect on our place in the world, our responsibility to safeguard the planet, and the urgent need for scientific inquiry and environmental stewardship. But perhaps the most profound impact of all is the way this mystery speaks to the human spirit. Throughout history, we've faced the unknown with awe and wonder. When we encounter something that challenges our understanding, something that can't be easily explained, it stirs something deep within us, a curiosity, a desire to understand, and a drive to explore. This event in the Atacama Desert isn't just a scientific curiosity, it's a testament to the power of human inquiry, the unyielding pursuit of knowledge, and the capacity for wonder that resides within each of us. In the end, whether this lake in the Atacama Desert is a clue from the cosmos, a geological anomaly, or something else entirely, it carries with it a profound message. The world is far more mysterious, far more interconnected, and far more full of potential than we can possibly comprehend. And as we continue to uncover these secrets, we are reminded that the journey of discovery is never truly over. There is always more to explore, more to learn, and more to understand, and that is the most exciting prospect of all. In the heart of one of the driest and most desolate places on Earth, a mysterious lake has appeared in the Atacama Desert, a phenomenon that defies the very nature of the environment it has found itself in. A place where water is as rare as life itself, this unexpected body of water raises questions that science, as of yet, cannot answer. From the very first moment this lake was discovered, the world has been captivated by the mystery of how and why it's there. Is it a natural geological event, an anomaly that suggests previously unknown processes in the Earth's crust? Could it be the result of an extraterrestrial event, like a meteorite impact that brought with it cosmic elements? Or is it the manifestation of something much deeper, a force within the planet itself, the release of deep Earth water that had been trapped for millions of years? As we've explored, each potential explanation holds its own weight, with intriguing implications that could change the way we understand our planet. The possibility that deep earth water is responsible suggests that the Earth's internal workings may be far more complex than we've ever realized. Water, a fundamental building block of life, could be far more abundant beneath the surface of the Earth than we've been led to believe, perhaps even more so than in our oceans. This could completely rewrite our understanding of Earth's geological processes and open the door to future discoveries that challenge everything we know about the planet's history and structure. On the other hand, the idea that the water could be tied to cosmic forces, perhaps a meteorite, a cosmic impact, or even water from an ancient celestial body, brings forth a deeper philosophical question: what if life, or the building blocks of life, are more universal than we could ever have imagined? What if Earth's unique nature isn't so unique after all? The possibility that this water has extraterrestrial origins challenges our very understanding of the universe and our place in it. Could we, as a species, be on the brink of realizing that we are part of a much larger, interconnected cosmic story? It's a thought that stirs both awe and existential curiosity about the universe's grand design and our role in it. As the theories continue to swirl, it becomes clear that the lake's appearance carries much more significance than just a natural phenomenon. It is a symbol, a reminder that there is still so much we don't know about our world. It reminds us that nature is full of surprises, that the Earth is more dynamic than we realize, and that scientific exploration is far from finished. The mystery of this lake forces us to confront our limitations in understanding and invites us to push the boundaries of knowledge, science, and curiosity. It calls us to look deeper into the Earth's hidden secrets and ask the tough questions, not only about how this lake formed but also about what other wonders lie beneath our feet, waiting to be uncovered. But beyond the scientific inquiry, the implications for humanity are equally profound. The appearance of this lake serves as a reminder of the interconnectedness of all things. If such an unusual event can occur in one of the most arid places on Earth, it reminds us that everything in nature is interwoven, and sometimes, the most unexpected things happen in places we least expect. This could serve as a metaphor for our own lives, urging us to remain open to the unknown, to be receptive to the mysteries that surround us, and to understand that we, too, are part of a larger, ever-changing picture. Whether this discovery leads to new scientific breakthroughs or sparks new philosophical questions, the lake's sudden appearance in the Atacama Desert will forever remain an enigma, one that challenges us to explore, to think deeply, and to continue our quest for understanding in a universe that is still full of mysteries. In the end, this lake in the Atacama Desert is more than just an anomaly. It is a call to explore the unknown and push the limits of human curiosity. It stands as a reminder that the Earth, and perhaps even the universe, holds far more secrets than we can imagine, and it is our duty, and our privilege, to seek them out. If you've found yourself as captivated by this mysterious lake as we have, make sure to hit that like button and subscribe to the channel for more deep dives into the unexplained. Who knows what other secrets the Earth might be hiding, waiting for us to uncover. Stay curious, stay engaged, and don't miss what's coming next. Until then, keep exploring the unknown with us.